Hi everyone, Miss Barker again. Today we're going to look at an example that uses both connections between the linear and angular quantities and uses angular kinematics or rotational kinematics. So in this example, we have a car starting from rest, and the car accelerates for 20 seconds with a constant linear acceleration of 0.8 meters per second squared. The radius of the tires is 0.33 meters. We want to see what angle is each wheel rotated through. So they give us information about the linear quantities in this case. They give us the linear acceleration, and we have to be able to identify that this linear acceleration that they're giving us is the tangential acceleration of the edge of the tire that has a radius of 0.33 meters. So for a rotational kinematics problem, we would use a grid for our givens. So here we're going to have our grid. However, I have some additional information that is not going to fit in the grid. So just like I would have for my one-dimensional or two-dimensional kinematics problems, I will put that additional information under the grid. So we have tangential acceleration is 0.800 meters per second squared, and the radius is 0.33 meters. We also know that the car tire starts from rest, so omega naught is 0. We're now going to use the linear information to find our angular quantity of alpha. So we know that tangential acceleration is r times alpha. So alpha is going to be the tangential acceleration over r. And we find that our alpha is 2.42 radians per second squared. So now I can take that and put that in up here into my grid, 2.42 radians per second squared. I was also given in this problem the time. So that was 20 seconds, so I'm going to put that in here. Now, my unknown, or my question mark in this case, is my delta theta. What angle does the tire rotate through? So then, now all I have to do is go to my list of constant angular acceleration equations and find one that only has delta theta as the only unknown. And in this case, that's pretty easy to do. We're going to select the equation for delta theta. In this case, since omega naught is 0, this term goes away. And now we can just simply substitute in our values. That will allow us to then find the angle that it rotates through, 484 radians. Now, in many problems, they'll tell you how many, they'll ask you how many revolutions does it go through. In this case, they just said, what angle is it? So we can leave this in radians. If they asked you how many revolutions did it go through, we would have to convert from radians to revolutions.